Hello and welcome everyone along to another edition of Algorand Developer Office Hours. I'm your host, Ryan Fox, developer advocate here at Algorand, and I am pleased to be joined by a couple of content creators here. Matt D, he is the creator of Algoworld, a series of collectible digital trading cards representing countries around the globe, as well as Cosimo, he is a solution architect here at Algorand. He is the creator of AlgoRealm, an altruistic gaming dApp using NFTs and royalty payments. And today our topic is going to be about NFTs, non-fungible tokens, specifically for collecting, gaming, and royalty payments. So we're thrilled to have these creators along with us, and the format of our show today is going to be a little bit of show and tell. So we're going to hear from each of them about the design and the implementation that they have for each of their NFT projects, as well as an overview of the smart contracts for gaming and royalty payments that we find in AlgoRealm. Let me get an introduction from each of you. Matt, welcome, and tell us a bit about yourself, where you are joining us from, and a quick overview about your project.
Thanks, Ryan. So, hi everybody, I'm Matt. I'm from France. I'm 34 years old. I'm an engineer in the real life, so I'm not a professional developer. I discovered Algorand a few months ago, and at first it was just to invest. I thought it was a great blockchain and with great tech and fast transactions and low fees. So at first it was just to invest, and quickly I saw that there was a lot of documentation and help to develop on it. And so I saw that there was possibility to develop an Algorand using Python, which is a language I know. So I had this idea of Algoworld, and I decided to build it on Algorand, and I thought it was the perfect blockchain to have a collectible card game on it. So, well, I will talk about Algoworld in detail. Just in a few words, Algoworld is a project based on 1,500 cards, and there are cards for each country in the world, for the 193 countries in the world. So each country has several cards, and each card has an NFT. Each card is an NFT, and so you can trade this NFT, collect it, and so it's really fun. It's a great way to discover the NFTs on Algorand, to see how it works, how you can have it in your wallet. So, well, I will talk about it in more details with my deck, but it was a small introduction to it.
Great. Thanks, Matt. We're thrilled to hear a little bit more about Algoworld later on. Cosimo, welcome. Tell us a little bit about yourself, where you're from, and what your project is about.
Okay, thank you, Ryan. So I'm Cosimo. I'm currently based in Italy. I'm a solution architect for Algorand. This means that I help use cases to be translated in Algorand protocol, and I currently mainly focus on the European time zone. And so as a part of the business development team here in Algorand, I provide technical support to be successful in translating an idea, a business idea, into an Algorand piece of protocol. So saying that, today I'm going to present AlgoRealm, that is a mini game on layer 1 that has been constructed just to show how you can extend the ASA framework with Teal to build your own NFT with royalty embedded policies directly in layer 1. And the game is very simple, and the hypothesis is that there is a reign, the Algorand reign, and we have two majesties that will rule over the reign, and to be entitled and get the crown of the chapter, you have to make a real algo small donation to the reward pools. That simply means you are paying a royalty to the overall ecosystem, and we will go into the details.
Well, wonderful, Cosimo. Thank you very much for doing this. And we can see you published a couple of weeks ago an article going over what AlgoRealm is all about on the developer portal as well. So developer.algorand.org, we can go and read about AlgoRealm there. Well, why don't you take us through that one? We'll go through AlgoRealm first, and then we'll come back and we'll take a look at AlgoWorld thereafter.
So wonderful. This is AlgoRealm, and during the presentation, we are going to learn how to extend the ASA, so the Algorand, the Standard Asset Framework, to create NFT on layer 1, just as I said. And we will discover that Teal is a very powerful tool to build on top the ASA framework and obtain your royalty policies over the NFT. But why we want to have royalties and NFT directly on layer 1? So what's the object of our development here? So first of all, NFT creator can benefit from future transaction involving those NFT, as since NFT are simply exploding. I believe that royalty schema and policies is a very useful tool to have directly on chain and keep going with gaining on your creation, maybe. Why run Algorand? Because it's extremely fast, cheap, and secure, thanks to the Algorand protocol. And since we are going to use several features like atomic swaps and smart contract, all embedded, having a cheap transaction is crucial, because we are not going just to exchange NFT. We are going to orchestrate them with a smart contract. So you can extend the SA framework, shaping your own royalty schema. So here we are going to learn how to implement based on AlgoRealm example, but please keep in mind that it's just an example. So it's not a real royalty. It's just an example how to do that. Okay. The agenda is what's AlgoRealm, what's the architecture, and then split the architecture in components. So we have a stateful components, we have the NFT created as an ASA, then we have a stateless component, and then at the end we will see how to bind them together to get the royalty embedded into the NFT on chain, and then some conclusion. So what's AlgoRealm? The whole point of the game is claiming the title of the majesty of Algorand. So AlgoRealm is a layer 1 game in which player can claim those NFT that represent your power and your sovereign title over Algorand realm. So to be entitled as a majesty, you should donate something to the as a royalty to the reward pools. And so since algos that go into the reward pools are automatically redistributed to every algo owner, this means that for each new block, this royalty will be redistributed somehow. So donating to the reward pool means actually that you are paying a royalty, and so that royalty has been collected proportionally by the whole ecosystem, by the whole Algorand. So the more generous is this donation, the harder it is to be dethroned and to lose the title. That's why only generous art will ever rule over the Algorand wheel. So simply, the game, very simple. Since the verifiable random function is the very heart of the Algorand protocol, I imagine that we have two majesties that represent the power over Algorand, that is the randomicity and the verifiability. So who possess the crown is the randomic majesty of Algorand, and who possess the scepter is the verifiable majesty of Algorand. Okay, so let's go into the details and having an overview. So AlgoRealm architecture binds this non-fungible ASA to an orchestration of stateful and stateless smart contract through an atomic transfer. So the atomic transfer is the glue that binds everything. And this will allow us to implement the royalties. So the AlgoRealm, we have several components. So the AlgoRealm app, that is the stateful Teal component, then the two NFT, the stateless one, who signs and approve the royalty payment in order to transfer the NFTs, and then the ecosystem royalty, that is the reward pool. So we have the components here. You have a claiming player, and you have the current majesty that currently own the crown, ASA, and then on the other side you have the reward pools that will collect the royalty, and you have an application, a stateful application, that will check if the royalty has been paid is higher than the previous one, and then you have the contract that sign everything. So first of all, the claiming player construct an atomic transfer consisting of 3 transactions. You call the application and say, okay, application, please check the amount of the second payment transaction, that is my royalty payment. And then if it's successful, then please call the stateless component that will sign and act as fallback address, transferring the NFT from the current majesty to the claiming player that paid the royalty to the reward pool. Okay, so this is simply the idea. Let's see each component in detail. So first of all, we have an application, and as all the application, we have a memory that is divided in global variables and local variables. So the purpose of a stateful application is reads and write variable on chain according to TIL branches. We do not use local variable here, so no opt-in is required. We just have 3 bytes sliced to integers. So they are initialized once the application is created. Okay, so the application calls are divided in 2 kinds in AlgoRealm. So the application responds to an AlgoRealm creation or an AlgoRealm action, that are different branches in TIL. And we do not manage update or delete anyhow, so nobody can change or remove AlgoRealm app from the chain. So what happens on the creation? You have a bunch of transactions that initialize some variables. Of course, the first majesty of Algorand is Silvio, and the first donation is 0. So this is the initialization round. Then a player or the creator can perform 2 kinds of action. The first is promulgating the law. This means updating the smart contract, declaring the address of the stateless component, and the other part is a claim executed by the player, and the actions are identified by group size, so the TIL contract know what we are going to do. In the promulgation, we simply ensure that the stateless part of the game that is computed after the instantiation of this contract can be updated only once. So once the law is promulgated, the law cannot be changed even by the application creator. And then once we, as a player, claim the title, we check that the claim is composed by a group transaction that first call the application, pass exactly 2 arguments, and then pay then transfer the NFT from the current owner to the claiming user. The claim that you can submit are 2 kinds. You can claim the crown or you can claim the chapter. And after the claim has been selected, so suppose that I'm claiming the crown, you can assign a title, so pass a nickname, saying Cosimo, and then the application checks whether the donation, so the amount of algo I'm paying to the reward pool, is higher than the previous one. So I'm being more generous than the previous majesty. This is the stateful part. So once the stateful part is on chain, you can create your NFT as an ASA. Here, as an ASA, you have to specify a creator, you have an asset name, And then the total supply is just 1 because the crown is unique, and decimal is 0 because the crown is not divisible. And you will get an asset ID. So once you specify the asset create transaction, you will get the asset ID. In the first step, all the ESA management that are the field that you can configure later on are set by default to the creator. So, and we will see why we'll change them after. So what's the stateless component? Since I'm going to hard code the asset ID and the application ID and reward pool into the TL code of the stateless component, I have to know that before compiling the source code in order to get the address, the compiling address. So the AlgoRealm needs an application ID, and now I got it because I deployed the stateful part. I got the asset ID because I've created the crown in the chapter, and I have all the information that you will see underlined here during the presentation. So first check, I check that I'm calling the AlgoRealm application. Otherwise, the stateless component will ignore the call, will not sign. And I check that you are calling the right application. Then I'm checking that you donate to the reward pool, and that the fact that who is donating is the same person who called the application. So the sender of the payment and the application call are the same. And then, since the amount of the payment transaction has been checked by the stateful component, the only thing that I will do is signing a clawback transaction either for a crown or the chapter. So only for these two assets. And then I had some security checks, and I will leave you exploring the guides on the developers portal as a guideline to each stateless part of the application. So rekeying address, access close to, and so on. So what's the magic now? That we are going to bind the crown ASA and the chapter ASA with the other components. So with the stateless that is binded to the stateful one. So as a creator, I'm going to issue an asset configuration transaction that will update the NFTs. And why I do that? Because I will specify that now the manager address has been canceled, so nobody can modify the contract, or sorry, the NFT anymore, and the freezing power has been removed, so nobody can freeze the crown or the chapter, and the clawback address has been assigned to the stateless part. So who will sign the clawback is the stateless component. Okay, so this conclude the description, and you can make use of freeze and clawback address to shape your royalties, and you can think about any kind of royalty schema. I will give you an example if I have time. Then you can take the AlgoRealm solution as a boilerplate to do that, and you can run your own node and try to claim the title and play the game. And this is also useful to see how to run a node, how to sign an atomic transfer, and everything is explained. Yeah, I will show you, for example, that exploring the application, you have here the TL decompiled source code, and you see that, oh, someone already claimed the title. So Silvio has been dethroned because the last transaction is 2 micro algos. So in order to claim the title, you should pay more. And you have the AlgoRealm law here, and you can see that the crown and the scepter, the amount of a transaction that has been signed. So someone 1 day ago claimed for the first time the NFTs. I want to create a general royalty scheme over NFT. So I have an NFT seller, an NFT buyer, and the NFT creator. And I will use a stateless account to sign the clawback transaction. Maybe, for example, this NFT could be issued as a default freeze ASA, so that the seller is not able to transfer it as he wish. So the NFT is default frozen ASA. This obliged me to pass through this mechanism to transfer it. So first of all, I can issue an atomic transfer that will be checked by the stateless component, and that forces me, 1, to pay some algo to the seller, of course. And then maybe the seller or the buyer, this is up to you, can pay a part of this price to the NFT creator as a royalty. And then if everything has been done correctly, the royalty contract account will sign the clawback that can have an higher power on the ASA, ignoring the freezing status. So he is able to take out the NFT and send to the buyer. The buyer needs to opt in, of course, previously. So this was another example.
Okay, and then Matt, bring up your session. We'll learn a little bit about Algoworld. Full disclosure, I own some Algoworld NFTs.
I begin with a little introduction of what is Algoworld. So Algoworld is a set of collectible cards. There are 1,500 cards and representing the 193 countries in the world, so they are all there. And each country has between 3 and 29 cards, mainly according to their population. And so each card has its own NFT. So there are 1,500 cards and 1,500 NFT. And NFT on Algorand is basically an Algorand standard asset, so an ESA of 1 unit. So these are ESA that you can manipulate, that you can have in your wallet, and then you can keep it, or you can trade it, sell it. It's all yours once you have it in your wallet. And that's the fun thing about NFTs on Algorand. It's that you directly have the NFT in your wallet, and you can do what you want with it very, very easily. So Algoworld is really a fun way to discover how it works, how you can have NFTs on Algorand. So, for instance, here we have the cards of Slovenia, which is a random example. So all the cards of the same country have the same picture, the same general design. You can see at the bottom right that there is a big number, the number 5. It means that this country has 5 cards, but each card has a specific ID at the bottom right. So each card is unique with its ID and its NFT. And well, it's one ESA, one standard asset for each card. And there is also another thing. It's the first card of a country has a special border, the famous diamond border, which means that this card is special, it's collector, and there is only one for each country. So the other important aspect is that cards are all sent through random packs of 5 cards. So you don't know what you will have until you get the cards, and it's a way to encourage trades and to push people to have trades and to send their cards to have the one that they want, because each one of us have a special connection with some countries. Of course, we all have our country, but we can have also other countries where we have friends, the countries of our ancestors. So it's always fun to have these cards, the cards of the countries that we like. And through this process of sending random packs, you don't have the guarantee that you will have this card. And so it's a way to push people to send their card to have the one that they want. And so it shows really how cheap and easy it is to manipulate these NFTs and to make transactions on Algorand. Because one transaction, the fact of sending one NFT, it's like 0.001 algo, so it's very cheap, and it's really fun to make some trades with these cards. The fact is that everything for now is based on trust. So as I will show on the next slide, we have a chat for now where we have a little community of Algoworld, and everything is based on trust, and trades are made on that, and it works very well for now, but it will be a possible improvement in the future to have a marketplace or something a little bit more elaborate to make some trades. So as I write it, there is no atomic transfer implemented yet or smart contract. So concerning the development part, I used Python with an Algorand SDK. So you must know that we can mint the NFTs and manipulate, make functions in the blockchain with Python and with an Algorand SDK, which is very simple and easy to use, I find. And there is also an API, PureStake, that I used, which is a way to connect to the blockchain. So I used Python with PureStake to mint the NFTs, and I used it to make the transactions and to send the cards. So we have this part with Python and PureStake for the minting, the transactions, the project description on the website, and finally all the sales and the trades between the members, which are made on the Telegram chat. So by the way, I know that there are some members with us tonight, so a little hello to them, and it's a really great community. I'm very happy with it. Algorand in general is a great community, and specifically Algoworld is a great community too, so thanks to them. About the properties, so the NFTs properties. We have 2 Algoworld wallets because there is a limitation. One wallet cannot have more than 1,000 assets in it, and as I have 1,500 assets, I had to split in 2 wallets. The asset name is quite generic. It's AW, then the ID of the card, then the country name, and then the number of the card on the total. And as it's an NFT, the total supply is 1. So you have 1 unit of this asset, and there are 1,500 of it, and no decimals, of course. So only one unit. So the URL, which is an optional field, is the website algoworld-nft.com, and we'll see later how I connect this NFT to the card. And an important point is the different addresses. And so, as you see, there is only one creator address, and all the other addresses are not filled, because I don't use a freeze address or clawback address or even manager address. That means that I have no control on these NFTs, and I can't even delete it. So once it's yours, and I can do anything to it. And I think it's an important aspect of NFTs in this case. You don't want to have the creator which can take back his NFTs. So here, all these fields are blank. Okay, so an important aspect is how I connected, or I made the link between the ASA and the card. And so the idea was to make it through the first transaction note. As you may know, for each transaction, you can add a little message, a little note. And so at the first transaction, you can see here at the bottom that I had a message which give the IPFS address and the HTTP address. So I will explain what it is. So IPFS, it's an interplanetary file system. It's a peer-to-peer protocol. It's like a more durable address than a simple URL on HTTP. And so it's like a metadata hash, and you have like a permanent address of the card, which is given here. And so you can, for instance, use a Brave browser to put this address, and you have the guarantee that it's more durable than a HTTP address, which means that if my website Algoworld NFT.com is down, this address, IPFS address, will still work. And if you take the card, the image of the card, and you want to prove that it's the right one, you can calculate this hash and obtain the same result. So it's like a guarantee that you have the good card. And there is also the HTTP address, which is a standard URL, and which is more convenient to use for day-to-day and just see the card. And it's basically always the same address, and with the ID of the card at the end. So we have all this information in the first transaction, and it stays on the blockchain as with AlgoExplorer.io. You can see all the first transactions of the assets. So it stays on the blockchain, and it's the way I found to have all the information that I wanted stored on the blockchain. So a little slide about how it looks to have the assets. So it's in your wallet. You have to, before receiving them, you have to add the assets in your wallet. And once you have it, you can see the assets, the cards that you've got in your wallet. So to add an asset, you have a functionality in the wallet. It's very simple. You click on add a new asset, you put the ID, and then you have the possibility to receive the assets. So when I send the cards, I sell it on the chat. I tell people to add the assets, and then I can send it to them. And after that, they do what they want with it. So as I told, Algoworld is, I think, a fun way to discover and manipulate NFTs on Algorand. There are 1,500 cards for the different countries in the world, and each card has its own ASIT, its own NFT that you can have in your wallet, that you can trade, and all that very easily, very fastly, because you can make transactions very easily on the Algorand blockchain. So each card is visible through the addresses, HTTP and IPFS addresses, which are noted in the first transaction. So as it's one of the first NFTs projects on Algorand, there are still some limitations. So you can see the cards directly in the Algorand wallet. You have to use the address to see it in a browser. The receiver has to add manually the assets before receiving them, so it's not fully automatic. And for now, there is no NFT marketplace or smart contract implemented for the trades, but I know that there are some projects which are in development, and we should have, I hope, in the near future, the possibility to use a marketplace to make very safe trades, even if for now the Telegram chat is working very well. So I hope that all these limitations could be lifted through future developments, but for now it's really a fun and great project to discover NFTs on Algorand.
We had a question from Kenneth that'll go towards Cosmos. The question has to do with, okay, it's great that you've got this concept of being able to take the scepter, become king of the realm by making this donation, but could the blockchain, could your smart contract take information from outside, such as, how about 500 likes on Twitter, and then that be the threshold that prompts the transfer of that scepter to the next person? So how can your smart contract be connected to the outside world, if at all?
Okay, thanks for the question. So connecting the blockchain to the outside world is an Oracle problem. So you have to trust the bridge between the world on-chain and the world off-chain. And you can do that in simple way or in very, very trustless way. So the more your Oracle is built as a trustless Oracle, the more I should not rely on your implementation or your centralized Oracle. But the short answer is yes. With an Oracle, whatever it is, you can take information from the outside world. It's a sensor or an API from a mapping service or a like on Twitter or whatever, and you can use an account to let this contract write on chain. So you can say, take those three variables. These variables in the contract can be updated only by this account that is the Oracle. So the backend of the Oracle do something, and then you sign with the Oracle an update of the smart contract. So if the Oracle instructed your smart contract, said, yeah, you get more than the threshold of like, then your contract will approve a transfer of an NFT, for example. So you have to split the application in two branches. Branch on Algorand is completely trustless because it's on chain. And the problem is figuring out how to connect and how to construct and form the Oracle to keep and retain those information from the outside world. But it is possible.
Good. Thanks, Cosimo. I appreciate that answer. Matt, I got one for you here. And so this gets to kind of your experience. You mentioned at the beginning that you are relatively new to joining the Algorand developer ecosystem. And I'm wondering about your experience. Did you download and install your node locally? Are you using Sandbox? Or kind of describe, what does your development environment look like?
Yeah, so as I said, I used an API to connect to the blockchain. So I used the PureStack API. That means that I didn't have to install my own node. I have my Python script and I connect to Algorand through this API which is a pure stake, and I didn't have to run my own node to make that. So I think that it's also a great possibility to develop and build things, projects on Algorand without having to have too much background or experience in development, because you have all these possibilities to use a simple language and an API to connect to Algorand.
Thanks, Matt. Cosimo, we got one here probably for you. Your role on the business solutions team, you're out there, you see all sorts of different use cases for ASAs, for assets, and for NFTs specifically. And I'm interested to find out what other unique applications for NFTs are outside of gaming and art, kind of what we're talking about today, but what else can you be using these NFTs for?
Okay, thank you for the question. So first of all, for example, I was involved on the CI application. So I was responsible for the architecture of CI, helping CI translating how you can tokenize intellectual properties. So this is a very important aspect. So tokenizing something that today is not that easy to be transacted with with trust, for example, authors exchanging intellectual properties. And I know that there is a lot of hype behind the NFT space, but as a solution architect, I do see really concrete use cases, for example, in tracking data or tokenizing data and exchanging data as unique representation. I'm not just talking about images or songs. Whatever kind of data can be tokenized uniquely. And for example, you can use NFT, as I said, to tokenize things that today is very hard to exchange, like CI.
Thank you. Matt, here's one about fees. So when you sat down and developed Algoworld, what did you think about the fees that it cost you to create each of those 1,500? Did you think that was a hindrance in any case? And then kind of what are your projections for going forward? Are the fees set adequately for content creators like yourself to be able to do this successfully, or are the fees too high?
Well, it's really cheap to build NFTs on Algoworld because well, it just, as I said, 0.001 algo to create, to mine NFT on Algorand. There is also the fact that you have to have 0.1 algo in your wallet for each ASA, which means for me that for 1,500 ASA, I had to have 150 algos, but it's very cheap, in fact, to build NFTs on Algorand, and I think that, of course, if tomorrow, in a couple of years, one algo is $100, it will be more expensive, but I think that there will be possibilities to adjust the fees. For now, I think it's quite cheap to build NFTs on Algorand and to trade the NFTs, and compared to other blockchains, it's really cheap and easy to build NFTs on Algorand. So for me, it's a big advantage of Algorand. It's not absolutely not a problem right now.
Good, thank you. Cosimo, how about from your side? Do you have anything to add? What do you hear from Business Solutions, the kind of the partners that you guys are out there talking with?
Yeah, so Algorand is a really good choice for tokenization for the reason Matt just mentioned. So, for example, the CI use cases would be simply not feasible in other blockchains, so which minting a new asset and transacting it costs very much more than Algorand, because, for example, they tokenize more than 4 million NFTs. So we are talking about a technology that should scale really. And what I just showed is also that orchestrating other transaction that has an impact or an effect on your NFT is possible, because you have to consider that you do not just create an NFT, but if you want to orchestrate an application like the simple game I just showed, you have to use a set of transactions. So maybe 3 or 4 transactions to call over the smart contract and then execute it. This is why it's even more important to keep the costs really, really low. And just one other question. As an electrical engineer, I really have a huge interest in sustainability. And this is why I recently published, for example, an article trying to figure out what's the carbon footprint of an NFT on Algorand. And this is very important because this is a great technology. It's scalable, but we would not like to burn out the world to use that.
I'm going to follow on with kind of what you just finished up there. A question from James. Get into your code just a little bit. So in the Algorand approval teal program and also the Algorand law teal program, he's noticing that there are checks that are identical on both sides. Can you talk a little bit about why that's required, or is that just a good practice?
We should go through the lines of code to have a very, very precise answer. But generally, I'd say, for example, if you want to check the price of a previous transaction, you have to push that check on the stateful part. So, of course, may seem that the checks are a little bit overlapped, but if you examine them one by one, they really are not an overlap, but they match with each other to be consistent and approve. If you need memory of the past, you check the things on the stateful component. If you really are interested only in what's happening right now in the transaction, in the block, you go stateless. So maybe seems a little bit overlap, but they are really doing something different. The first one has to do with the past and the memory. The other thing is the current state of the block and the transaction.
Matt, I think I'm going to try to send the final question to you here. So Espen again asked a question that has to do with designing a smart contract or a set of smart contracts such that they are holding 2 different assets. So I think the example here would be, 2 different Algoworld cards, and they want to put together into an atomic transfer that both of those cards are going to come from one and go to the other. So is this possible even if as your NFTs are designed does not have the management clawback or freeze address included? So ultimately this boils down to, can a smart contract be developed to hold 2 different ASAs and then allow them to be swapped?
I think Cosimo will help me with this one, because I'm not a specialist in a smart contract. But as I understood it, yes, it would be possible. But
okay. So nothing in the design of your NFTs that don't implement those fields would prevent that from happening.
As long as the address of the smart contract has the assets in it. The smart contract can send it to another address without any problem, as I understood it. I don't know if you confirm that.
Yeah, of course. Yeah. all the details that you want to implement to exchange that ASA that NFT are completely feasible. The first limit, the only limitation you have because you canceled out the management address before the deployment of a smart contract, is that you cannot delegate, for example, the freezing logic or the clawback logic of those NFT to a smart contract. This means that, for example, we cannot implement a royalty as I have done, because for all you guys who want to develop in Algorand, you should know that you have a sequence of the deployment, because you have to get the information first, and then you have to reconfigure the things. So there is a timeline of deployment in your components, and I described it in the solution. But other than managing a royalty, you can instruct in several ways a smart contract to handle your NFT, Matt. Yes.
Special thanks to both Cosimo and Matt here for joining Developer Office Hours today and sharing their projects, both the AlgoRealm and Algoworld. There are decks available for each one here. They have the short and bit.ly links. I thank you both for joining us and for showing us around your projects.
My pleasure. My pleasure.
My pleasure too.